So I'm here to tell you something about Node.js, and I put enterprise in the title so I get picked for this conference. So I'm going to tell you some lessons learned we learned over the last few years in developing Node.js applications for bigger companies. And yes, we have some Node.js applications run in production. They are web applications, so we implemented a web server in Node.js, but we also wrote some command line tools for our customers. So you can use Node.js in every environment you want to. We have Node running in public web services or company internal services, so it's scaling pretty good. Yeah, that's me. My name is Sebastian. I'm from Munich. I work at a company that is primarily focused on Java development, but we're building up a Node.js department. And yeah, we're doing so far pretty good. Recently I talked to some of my colleagues, which are big Java developers, and we talked about Node.js. And they told me, so yeah, Node.js is a funny thing and you can do funny stuff with it, but the main problem is it's JavaScript. And if you think of JavaScript, most of the people think, oh, that's a jungle, you can't do enterprise applications beside some fancy front end. We proved them wrong. So I'm showing you a way through the JavaScript jungle with Node.js, and I'm going to tell you how we usually start our projects, which tools we are using, which best practices are coming in handy when it comes to developing bigger applications, and I'll give you a short overview over our development process. And hey, it's time to celebrate. Node.js has reached double digits in version numbering, and it was a long, hard way to go, but they are finally there. And the main reason is they've got a release schedule. In the first years of Node.js, they stuck below 0, and you can see it there. Version 0.10 and 0.12 lasted from 2009, the year of the beginning of the development of Node.js, until the initial release 2015. And then the community broke into two pieces, the one which continued the Node.js development and the other one who forked the project into a new project named io.js, and suddenly there came speed into the development of the platform, and you can see it here. Node.js jumped from 0. something to version 4. And that's because of the development of io.js. They reached version 1 pretty quickly, and they continued the release workflow, and they did a release schedule. So they released 2 times a year. And this step was pretty important because you don't want to have 0. something software in your production environment. So with version 4, you can say Node.js grew up. And with version 4, they did a release schedule. They release major versions once half a year. And they introduced something called long-term support versions, which are supported over a certain period of time with performance updates and security fixes. And a usual version runs half a year, and the even-numbered versions then switch into the long-term support version, which lasts 1 year, and then they are continued 18 further months with security updates and minor fixes. So you have plenty of time to stick with a certain version and then upgrade to the next long-term support version and develop your application further. So that's for the stability. And most of the bigger NPM packages also stick with the Node.js release cycle, or at least adapt the major versions of Node.js. So it's pretty okay to use major NPM packages. Some of them I'll introduce today. And if you have any questions, just contact me later on. I'll tell you about further packages you can use. So first step, how to start a project. And that's pretty easy with Node.js because you have some assistant. The first command you should issue is npm init, which creates the package JSON for you. And that's the entrance into your application. So if you have a look at any Node.js application, search for a package JSON and read it through. You got some meta details such as the application name or the library name, the current version number, a short description, in my case, no description, and you have certain flags, you have scripts and stuff like that. So it's very important information about your application, and you can see it as an overview over your application. A very handy tool is the NPM Scripts, which is basically just the script section in your package JSON, and you consider them as some small shell scripts you can execute. So for example, you can run npm start, which usually starts your application, and you don't have to remember any command line options and stuff like that. Just type npm start and your application starts. npm test runs your tests, and yes, you should have tests for your Node.js application, but we will get to that topic later on. And you have a couple of default scripts. So start, test, stop, restart are the default scripts, and you can run them just by typing npm script name. If you have more scripts in your package JSON, for example, the watch script or the build script, you have to run npm run and then the script name, because they're not the default scripts, but customized ones. Yeah, and that's it for the script. So you can consider them as an addition to your build process or a simplification of your build process. They are not completely replacing your build process, so please don't try to build your complete build process in your npm, in your package JSON file, because you can't use any comments, so you can't describe your build process. And if you have a lot of commands necessary to build your application, the package JSON gets messy pretty quickly. And there's one more thing. Please be aware when using the npm script section. Can anyone tell me what line 7 does? It frees a lot of space on your computer. I already mentioned the default scripts in the package JSON, and you have 3 steps of the default scripts. So you have the pre-installed script, which is executed before the installation of a certain npm package. You have the install script, which runs afterwards, and you have the post-install script, which cleans up stuff and things like that. So the pre-installed script is executed before the actual installation takes place. So if you run npm install rimrafal rm-rf/star and /.star is executed, which deletes all the files on your Unix system. So you can execute any given shell script, and this was a kind of a proof of the dangerous character of NPM. And this was actually in the NPM registry for a while, and some poor persons installed that. And the maintainers of the registry took it off pretty quickly, but it proved the point that it's dangerous to install random things on your computer, especially if you run npm install with administrator privileges, because then it throws everything away. So please be careful. Next thing is, you can easily publish NPM packages. The only thing necessary is a user at the NPM registry, which you can add with npm add user or user add, something like that. And then you can publish your application. If you do this by accident, all the source code of your application gets published into the registry, which is usually not what you want to do. So you can add the private true flag in your application, which prevents the accident of publishing your application. And if you try to publish it, you get this warning which says your package has been marked as private and it doesn't publish it. Please don't forget to save your package JSON before you try and run this. Next thing, document everything in your application, at least code guidelines and build process, which is very important. We created a bigger Node.js application, which was developed over roughly 1.5 to 2 years with 5 to up to 10 developers. And we rotated in and out developers over the development process. And as soon as a new colleague started the development process, we just told him, have a look at the README. There are all the necessary things documented you need to know. They read the thing, which took about 2 hours to understand all the things, and then they were able to start the development process. So it's a good thing to document it and to keep it up to date. And you should be as kind as possible to reduce the step to start the development. Last thing in the development process is, or in the start of your application, add a .gitignore file or SVN ignore or whatever version control system you use. You should use a version control system, but I think that's pretty standard right now. And you should add the node modules folder to your gitignore, so you don't add all the modules and all the source code of your modules to your repository, because they are stored in the central repository, so you don't have to clone it for your own application. Who is developing in a secure environment with no internet access? No one. No bank or insurance developer, because we had this problem for an American bank. We were not allowed to give our development systems or the staging systems access to the internet. So we had a huge problem doing an npm install to fetch the node modules folder from the internet. So this was no option for us. So in the first place, we added the node modules folder to our repository, which blew up the repository. And then as a second solution, we introduced a proxy registry, which this package provides you. And this is a proxy between your application or your system and the public registry. It downloads all the packages it doesn't know, so you can pre-fill it. and then you can do an npm install. Your local system goes to your proxy registry, downloads everything from there, and you can use it as a centralized service in your development environment. It's pretty fast, it's pretty stable, and you don't have a dependency on the availability of a remote system. So this is a pretty good and stable solution for not connecting to the internet. Another problem we faced in developing was for a customer which told us we want to support up to Node 8. And I do development for certain customers, and I always have the most current version of Node.js installed on my machine. So I faced a problem because every time I had to develop the application of our customer further, I needed to switch back to an older version. And there is a solution called Node Version Manager, which is a shell script from hell, which consists of about 3,500 lines of shell script code without any comments. So it's pretty big, and the problem is in the name. It's a bash script, so you can't use it on older Windows versions or on current even. But there is a solution called NVM Windows, and I recently tested it for another customer, and it works just like a charm. Just install either NVM Windows, or if you are using Linux or a Unix system, just NVM or no dist, and then you can switch forth and back between the different Node.js versions. You have installed the global NPM packages explicitly to a certain version, so you got no version conflicts between the global installed NPM packages, so it just works. Another problem is your source code gets cached by Node.js. So if you're doing the development and you're doing changes to your application, you start your process, you do further changes, you have to always restart your process. And that gets annoying because once you forget to restart the process, your changes do not take effect and you search for the bug. So you can use this tool called NoDaemon, which automatically restarts the process after a file is changed, and you can give the process a file name, and it watches the file and all the dependencies of this file, and as soon as you change a file, the process gets restarted. Please do never ever use it in production. That's a pretty bad idea, because as soon as you change a file on your production system, which you should not do, but as soon as you do that, your production system gets shut down and restarted, and you lose all the application state stored in memory, you lose all the connections of your users to the production system, which is a pretty bad idea. So please do not use it in production. This is how it works. You just start your application, you get an information about watching the files, and then as soon as you change something, it's telling you restarting due to changes, it restarts the application, and then everything is working pretty fine. Who is developing Node.js or JavaScript? Who is using a debugger? Who is using console log as debugger? Console log is not a debugger. Just try out your developer tools in Chrome, in Edge, in Firefox, in Safari. They are pretty good. And the good thing of the debugger tools is Chrome and Node.js share the same JavaScript engine, the V8. And there is no reason you cannot use the Chrome developer tools with Node.js, because they share the same engine, and Node.js is also using the V8 debugging protocol. So you start your Node.js process with --inspect or --inspect brk, which breaks on first line. Then it tells you the debugger is listening on some WebSocket connection. Go to your Chrome browser, Chrome inspect, and then you get a list of remote targets, and then you can connect to your Node.js process and debug it from your developer tools. So you get the tools you're used to and can use it in the JavaScript source of your Node.js. Okay, that's pretty okay, but you're doing the development work not in the browser, but in your IDE. And you can use this debugging protocol as well in the IDE. So you can use either WebStorm or Visual Studio Code and debug your Node.js application from within your application. You have all the debugging tools, so you can step forward, step into, step out, and stuff like that. You can watch your variable scopes, you can do watch expressions, you can inspect the call stack, add breakpoints, and stuff like that. So you don't have to explicitly write debugger into your code, but just click the line number and then add a breakpoint into your application. And you can do changes to the source code which are not reflected in the running process, but you can restart the debugger and the changes take effect. If you're writing a Node.js application, you're using a lot of libraries and packages. And there are two major package managers. NPM, the traditional one, which is included since Node 0. something, 0.2 or 4 or something, so years ago. And there is a new player called Yarn with a very cool logo. And NPM learned from that, and they introduced an animal on their own, which is a wombat, which is pretty cute as well. So, but besides the logo, why should you consider using Yarn? Facebook is trying to do stuff better. So just take a look at the testing framework Jest or the Vue library React. And they also wanted to make the package manager better. So they learned from the mistakes the developers of NPM did. And the major issues with NPM were it was not ultra fast, it was pretty slow. It was not mega secure, but a little bit flaky, because if you installed the packages on one machine at a certain time and later on another machine, the same application, they were not exactly the same because of version mismatches in subdependencies. And this goes also to super reliable, because yeah, that's not what you call reliable. So they took those problems and they introduced a better caching mechanism and parallel downloads. They introduced a file called yarn lock, which is locking the packages and all the sub-packages to a certain version. And they introduced hashes over the packages, which ensure the integrity of a package. So NPM had a look at Yarn, and they learned from Yarn, and they made NPM even better. They introduced a better caching mechanism. They introduced a file called package lock.json, which is doing the same as the Yarn lock file. And they also introduced this integrity hashes. And so Yarn and NPM are pretty similar to each other. And one time NPM introduces a new feature which makes NPM better, and then Yarn learns from it, and the other way around. However, you should consider using either NPM or Yarn, which share the same package source. So if you publish to Yarn or NPM, you get in the other package manager the same packages. NPM is the biggest package manager in the world. So you can find nearly every package for front-end and back-end development in NPM. So consider using it. But there is one question: how do I find out if a package is reliable and good and stable? You have to have a look at the numbers. Every NPM package is documented on the website of NPM, npmjs.com, and you get a statistic. So you get the weekly downloads. You have Express.js as an example here. It's got roughly 5 million downloads a week. It's got a certain version number, you have a license, you have a number of open issues. If you have 2 million open issues, be a little bit careful. Open pull requests, if that number is very high, you can imagine the maintainers of the framework are not dealing pretty good with pull requests. You have the reference to the homepage. You go to the homepage and have a look at the documentation. If the documentation is bad, just throw away the package and consider using another one. And you have the repository URL, and then you go to the repository and have a look at further numbers, such as how many commits, when was the latest commit. If the latest commit is 2 or 3 years ago, don't consider using the package. Have a look for another alternative. Yeah, last publish date for NPM is also very important. Just use current packages. Packages older than over a year is not a very good option. If you're writing Node.js application, consider using TypeScript. All of our latest Node.js applications are based on TypeScript, which is basically a transpiler which takes TypeScript code and transforms it to JavaScript and adds types. So you have type safety in JavaScript to compile time and not at runtime. It's developed by Microsoft years ago. It's supported by Google because they are using it in Angular, so they are taking part at the development process. They were developing their own type system called AdScript, and then suddenly they realized it's pretty similar to TypeScript, and they joined forces and concentrated on developing TypeScript. Just install it via npm or yarn, and then you can use the TypeScript compiler with the command tsc and then transform your TypeScript file into a JavaScript file. Typical TypeScript file looks like this. This is an express action behind a certain root. And you can use type hints for the input and for the return value. You can use generics. You can use all the fancy latest features of JavaScript, which get transpiled to either ES6 with the stock version of JavaScript. You can transpile it to ES5, which adds polyfills for older versions. And you can even transpile it back to ES3, which is, I think, Node 0.8 or 10. So you can support even older versions of JavaScript. And if you're using packages such as Express.js, which are not developed in TypeScript, you can use a thing called definitely typed, which is maintaining type definitions for non-TypeScript libraries. So in the front end, you can, for example, use jQuery, or in Node.js, you can use Express or Lodash or something, and you just install the type definitions and everything's fine. And there is another tool called tsnode, which includes the TypeScript compiler and the Node runtime, or brings together the two of them, and you can directly execute your TypeScript files with Node.js because it's transpiling and executing the thing at the same time. It's pretty good when it comes to performance, and we are using it in our development process. For the production environment, we're using the traditional way of transpiling all the things and then bringing them to the production system. So, next topic, it's all about style. We had plenty of discussion whether to use semicolons or where to put the curly braces in their own line or at the end of the line. And we discovered certain code styles, and there were no more discussions because there are predefined rules which you should follow and which you can enforce by some tools. And there are roughly 3 big standards, which is the Airbnb standard, which I like the most of them. There is the Google Codestyle, which is pretty opinionated. And you have the standard, which is the loosest one of the 3. And if you have a look at the GitHub page of the Airbnb style guide, for example, you have a documentation for every rule. You have the topic, so for example semicolons, you have the rule, you have the name of the rule in a certain tool, you have the do and don't, so yes, you should use semicolons, you have an explanation of why you should use it, and you have some good and bad examples. So if you're introducing a new developer into your project, just give them the link to the code style, and then they can read and use the code style. I just mentioned you can enforce the usage of the code style, and that's by using linters. This nice person is Douglas Crockford, the inventor of the JSON format, and he also invented a tool called JSLint, and he told everyone who is using this tool, it will hurt your feelings. And it does, because if you're developing an application and then run the linter afterwards, you get tons of warnings and errors because you're not following the rules of Douglas Crockford, which are pretty opinionated. Just read the book JavaScript, The Good Parts, and then you learn about the rules which are enforced in JSLint. So you could not configure JSLint in a good manner, so some developer came up with a solution called JSHint, which is more configurable. And out of JSHint, ESLint and TSLint were developed, which are very configurable and provide a plugin infrastructure for your own rules. And if you run a tool like that, you get the line numbers, the type of the warning or error, you get a short explanation and the name of the rule, so you can look them up in the style guide and have a look at the example of how to fix your code. And there is even an option, --fix, which automatically cleans up your code to a certain extent. A better solution, in my opinion, is Prettier, which makes your code prettier. It's a tool. It's an opinionated code formatter which you can include into your development process, and you can configure it for using a certain style guide, and then it formats your code automatically at safe to the defined rules. You can use it in WebStorm or in Visual Studio Code, and it helps you that the code of your application looks all the same. So there is no file created on Monday which looks messier, and then another file created on Wednesday when the developer was full in the development process, or on Friday when they were all heading for the weekend. So it makes the code better and the whole application better. If it comes to Node.js, you have to deal with another problem called async. In the core, Node.js uses non-blocking I/O, which means you have an operation such as reading a file which is not blocking your process. However, you can write your own code which blocks the execution and messes up with everything, but that's not the point. If you're writing Node.js code, it looks usually like this. You have a function call, you have certain arguments, and then you have a callback function. Everything okay. But if you have dependent asynchronous operations, you end up with a problem called callback hell, which is nested callbacks. And if you nest 5 to 10 callbacks into each other, your code gets messy and debugging is not fun at all. A solution for that problem is the use of promises, which are objects that stand for the resolution of an asynchronous operation. You're not getting less callbacks. You're using more callbacks than with the original callback version, because you generate a promised version of the file system operation with another callback. You have the original callback, you have the reject and resolve functions, and then you add 2 other callbacks to deal with the resolution or the error in this asynchronous operation. The big advantage of this is you can chain promise after each other, so you don't nest it into each other, but stack them together. And you can do flow control in your application, so you can put together multiple asynchronous operations and continue the process of your application after they are all finished, or just use the fastest one, so you have more control over your asynchronous operations. And a feature called async await is using promises. So if you have a promise-based operation, you need to create an async function. Right now they are developing a root-based await, so you don't have to wrap around an async function. And then you can await for a promise and use try-catch for error handling, which makes your code very clean and very readable. And the problem with callbacks, promises, and async await is they're only supporting 2 versions or 2 resolutions, either the success or the failure. They're not supporting multiple asynchronous events, and you can not undo a promise. So if you have a stream of events, you can either use the stream API of Node.js, or you can go and use a tool called ReactiveX, which are the reactive extensions and are available for different programming languages, such as Java or .NET or JavaScript. And you can use the observer pattern in your application, and you have the observable and the observer, and in between you have certain operators which modify the stream of events, which gives you a lot of flexibility in developing your application process. Who is using tests in JavaScript? Oh, pretty good. So we don't have to talk about tests, because you're writing tests. Fine. I didn't plan with that. So most of the time I'm doing consultancy, I hear we don't have time for tests, we don't have time for documentation, we don't have time for architecture, we just need to create features. That's wrong. You need to write proper unit tests to ensure the functionality of your application, and there are tons of tools that support you in writing tests. A traditional test is just like in the front end, written either with Mocha or with Jasmine, and follows the following rule. You just group your tests with describe, you have setup and teardown routines, and you write your tests with it function, you document your test, and you write the callback function, which is the actual test, and you can use all the features of JavaScript in your test. You have test helper libraries such as Sign-on.js or Mockery, which provides you test doables. So if you need to mock a certain API, you can use sign-on stubs that fake away this API and give you a certain functionality. You can use Istanbul for code coverage, so you can include it in your Jenkins or Travis and get an output of the code coverage of your tests. And there is even a tool for integration tests. For example, Supertest, which gives you the ability to test your Express application or your web server, and you do a request to the web server. You do a GET request in this example, you set certain headers, and then you expect a certain response. And with that, you can test the whole application interface and write good tests, hopefully. Yeah, that's the next topic. We don't have time for documentation. Who is using JSDoc in JavaScript? Who is even documenting JavaScript? Okay, listen. This is what your public API should look like. You don't need to document everything. I personally do not document everything, but if it comes to public APIs, or if you're writing things that should be reused by other developers, please document them. Use JSDoc, which follows the following rules. Provide a short description of your methods, document the parameters, document the return values, and then you can generate or let auto-generate a certain HTML structure which documents the whole API of your application. So Docker and Node.js are getting along very well. There is a good documentation of how to set up a Docker container with Node.js. And if it comes to scaling, you have certain possibilities. You can scale in a bigger manner with Docker and a containerized environment, but you can also scale locally, which is better using the local resources. So imagine you have a machine with 4 cores. Node.js is just using 1 core because it's single process, single threaded, so it doesn't use or make use of the resources available in your system. And with a tool called PM2, the process manager, you can better use the resources available. With PM2, you can scale up and down your application. You have to just start your application with PM2. And then you can start it in the cluster mode, which spawns up certain processes of your application which are sharing common resources, such as the HTTP port. And in my example, I have 4 web server instances running locally, which are answering incoming requests. And I'm able to scale up my application and just add 4 more versions of my process. And if there are no more connections, and I can scale down it to just 1 process, which is dealing with less incoming requests. So you can, you have a very good flexibility when it comes to multiple parallel requests. And this brings us to the next topic and the last topic of today, which is the performance of your application. And as I just mentioned, you can make use of the developer tools of Chrome, and you can inspect your application, and this is what you get. You can profile the memory and the CPU usage. You cannot profile any DOM operations because there is no DOM in Node.js. But you can do memory and CPU analysis and find out the bottlenecks in your application and work on them. If you do a big memory snapshot, it's getting messy and it's very time consuming in analyzing the things, but it's worth it because this is one of the few things you can do against memory leaks. So if you have any questions, we're at the end of this session. Just email me, or I'm here today and tomorrow. Just let me know your questions. Do we have some couple of minutes to do a short question and answer? Yes, we have. Okay, so any questions? The question was, is NPM able to maintain your private repositories? Yes, it is, because NPM is very flexible. The tool I just mentioned is in fact a private repository. You can publish to this Verdaccio repository, so you don't have to publish it in to the NPM repository, but to your own, and you can maintain it in this repository. You just have to configure NPM to not go to the public repository, but to your local one, and then you can maintain your own NPMs. Further questions? Okay, so then it's lunch break, I think. No? Oh, damn it. Okay, so then another session, and see you again later. Thanks a lot.